All right, starting lesson 9.6b. All right, counting principles. Now, the first key term is a permutation. All right, now permutation is the number of ways a set of elements can be ordered. Ordered is the key word. All right, order matters when you're talking about permutations. Okay, so for example, if you're lining people up in terms of height, from tallest to smallest, that means that the order matters. That's one example. All right, so the number of permutations of n elements is simply n factorial. All right, example 1, in how many ways can 8 children line up in a row? Okay, so here we have, essentially, we could have slots. All right, so who gets the first slot? Well, there's 8 choices. And then who gets the second slot? Well, then we have 7 choices, and then 6, 5, 4, 3, 2, 1. All right, oops, didn't need that extra box. All right, so this is equal to 8 factorial, which is equal to 40,320. All right, and once again, order matters. So say Tim was put in this spot. That's different than Tim being put in this spot on the other end. Okay, order matters. Example 2, a coin club has 5 members. In how many ways can a president and vice president be selected from its members? Okay, so you have 5 members, 1 president and 1 vice president. Okay, so essentially you have 2 slots. You have 1 for president, you have 1 for vice president. So for president, how many choices do you have? Well, you first have 5 choices. And then when you're looking to fill the vice president position, you have 4 choices left. Okay, so that's 5 times 4, which is equal to 20. All right, now we could have used a particular formula right here, which we'll find in the next example. All right, permutations of n elements take an r at a time. All right, so you have a certain amount to choose from, but you're not using all of them. Okay, you're using r of those n elements. So here we have NPR. All right, now what does this all mean? The first little number here stands for how many elements you have to choose from. This small number here represents how many of those elements you're choosing. Okay, so then we have n factorial over n minus r factorial. And you could apply this formula to the previous example and you get the same result. All right, example 3, apply the above formula to example 2. Oh, so here we're going to do it. So I have 5. I'm working with permutations and I'm choosing 2 from the 5. Because I have 2 positions that need to be filled. So then I have 5 factorial over 5 minus 2 factorial. And that's equal to 5 factorial over 3 factorial, which is equal to 5 times 4, which is 20. Alrighty. All right, going on to the next idea, distinguishable permutations. Okay, so this right here, number of elements to choose from, this is a particular ordering. Okay, if I switch these 2 A's, I get the same permutation. It looks exactly the same. So those wouldn't be distinguishable. Now when we use this formula, we want all the orderings to look different when we're looking at them. And this formula gives that to you. So the n represents how many elements you have to choose from. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements to choose from. All right. And then all these n's on the bottom represent the amount of each particular letter that you have available. So I have 2 A's, so I'm going to write 2 factorial. And then I have 3 E's, so I'm going to write 3 factorial. And then I have 2 P's, so I'm going to write 2 factorial. And for the J, we could write 1 factorial, and for the R, we could write 1 factorial, but 1 factorial is 1. All right, so you don't really need that. All right, now, we could work this out by hand. I could just write 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 2 times 1 times 3 times 2 times 1 times 2 times 1. All right, and we can just start canceling values out. The 2 goes into 8 4 times. The 3 goes into 9 3 times. The 2's cancel out here. 2 goes into 6 3 times. Okay, and if we multiply this all out, we get 15,120. All right, once again, I want to emphasize the idea that if I just switch these two A's, I get the same ordering, and I don't want to count that ordering twice if it looks the same. So this formula cancels out that repetition, and that's why you're dividing by the factorial of however many letters you have for a particular letter. All right, because that cancels out the repetition. All right, example 5, in how many ways can the letters be written? All right, so same approach here. This is distinguishable permutations. It says how many ways can the letters be written. All right, so we're going to use 5 factorial here over, now how many p's do I see? There's 2 p's. So there's a repetition of 2. All right, so I end up with 60. And now for committee, I have 9 letters total. And I have, let's see, I got 2 m's divided by 2 factorial, 2 t's divided by 2 factorial, and I got 2 e's divided by 2 factorial. Alrighty, so working this all out, I get 45,360. Done. All right, one last example. Okay, for this particular equation, I have to apply the permutations formula. So I'm going to have, let's see here, it's going to be n factorial over n minus 5 factorial. And it's equal to 18 times, let's see, I'm going to have n minus 2 factorial over n minus 2 minus 4 factorial. All right, so what do I do here? Let's simplify this. N factorial over n minus 5 factorial is equal to 18. I have n minus 2 factorial over n minus 6 factorial. Okay, what am I going to do here? Now I need to get rid of the fractions, so what I'm going to do is multiply by n minus 5 factorial. All right, so these cancel out here. And I'm left with n factorial is equal to 18 times n minus 2 factorial over n minus 6 factorial. And I'm going to strategize a bit here with this n minus 5 factorial. I'm going to expand it. So what's the next term in the expansion? It's n minus 5 minus 1, which is n minus 6. All right, so that cancels out there. And then, let's see, I have n factorial is equal to 18 times n minus 2 factorial times n minus 5. Okay? And what's the next step? Gotta strategize once again. I gotta get this to cancel out some way, somehow, because it's just gonna go on forever when I expand it. Oh, so I could take this here and expand it. There we go, and stop at the n minus 2. There we go. Okay. And so now I divide by this. And that cancels out. All right, then I have n squared minus n is equal to 18n minus 90. Move everything over to the left side, and I get n squared minus 19n plus 90. And that's equal to 0. Okay, and now I'm going to apply the big X method. Gotta find two numbers that add up to negative 19, multiply, give me 90. That's negative 9 and negative 10. So I end up with n minus 9 times n minus 10. And that's equal to 0. All right, so I have n equals 9 and n equals 10. And there are two solutions for this problem. So both of these values actually make the equation work. All right, if you have any questions, please make sure to ask. Begin the assignment.